So a good late afternoon, and I know we're in the process of losing both mass and momentum here. So, but it's still my pleasure to invite our keynote speaker, the end of this session. Is Ian Hamilton. He is a reader at University College London Energy Institute. He's with the Bartlett School of Environment, Energy and Resources, Faculty of Built Environment at UCL. His research interest is focused on the nexus between energy demand, energy technologies, and energy efficiency, sustainable cities, indoor and urban environmental conditions, and health. He is the operating agent for the International Energy Agency in buildings and communities. And so with that, I would like to welcome Ian to make the final remarks for our conference. Thank you.
Thank you very much. So I'm going to step both up a bit and over a bit, in the sense of what I'd like to talk to you today is an overview of some of the work I've been doing at the International Energy Agency, of which I've been seconded to for the last number of months. And this is looking at energy efficiency trends globally in the building sector. And I think what I would like to be able to do is give you, I think we are very focused on what's in front of us, our communities that we're working with, our sectors that we're working with, the stakeholders. What I'd like to do is be able to give you what's going on overall in the trends, and really where we're going and where we need to go. So just a few weeks ago, or the other week, we launched the Energy Efficiency Market Report for 2018, and I was a co-author for the Buildings chapter, along with a colleague, Brian Dean, and another colleague, sorry, John. So just to quickly say, I am at UCL, and I've been involved in lots of various different research around built environment, in particular energy demand and impact on from energy technologies. But I'm going to talk to you mostly now about this report, and also then some of the work we're doing at UCL in addressing that. So really, what are we here for? Well, primarily it's around building an energy efficient, sustainable, and equitable society. And this is really important to know, that as we go forward globally, we're going to see, as we have here, there's growth in energy demand. And now there's been a curtailment in the last few years, but this 2017 is going to be the highest growth we've seen in certainly the last number of years. And the worrying trend behind that could be that as we continue to demand more energy, on one hand, that's a good thing for many in the world. There are many who do not use enough to satisfy their needs. But at the same time, that's probably not necessarily where all the growth is happening. And so as we go around global energy use with and without energy efficiency improvements, one of the things that we do see are these trends. GDP continues to rise. Obviously, that's an important feature in terms of economic prosperity. Actual demand has actually traveled along, but has decoupled from GDP for the most part, and that's very important. Had we not introduced energy efficiency, and by that I mean the uptake of technologies and better building practices and regulations around curtailment, this would be much higher than it currently is, and it would be more coupled. One of the things that we work together with the agency is actually defining what a more energy efficient world would look like, and this is what this new report is doing, is looking at the efficient world and devising a scenario around that. And really, it's important to know if we miss the opportunity of energy efficiency, we're, of course, as been noted, we're locking ourselves into not only a high energy future, but the risk, of course, is a high carbon future. So what the scenario was really focused on was saying, what would happen if by 2040, countries were to realize these economically efficient investments in energy efficiency in terms of the economy, the energy system, and the environment. So one thing, GDP and energy demand, as shown here by this figure on the left. By 2040, we expect that GDP would double, while energy demand would increase only a small amount. And this is really important to be able to say, we are not going to limit prosperity. It's got to be about enabling that equity through the availability of the energy resources we have to our use, but in doing so in a sustainable way. But what does that really look like? On one hand, we have greenhouse gas emission trends, and you see the left-hand lighter bar on the top, which is if we were to institute only what we've said we would do now, and that includes the commitments that countries, and Canada included, have made around its nationally determined contributions. And what the green line is illustrating is where we would need to be going in terms of greenhouse gas emissions. Now, this is under the efficient world scenario, and what does that mean in terms of real people's lives? Air quality is one of the big ones. We know globally that energy, fossil fuel, industries are producing a lot of the pollutants that, as the WHO said recently and earlier this summer, 90% of the world's children live in air that is polluted. 80% of the global population live in that air. So the problem here is, of course, that our energy use is having tangible impacts on environment, which we realize, and ultimately on our health, which is certainly not in our interest. The efficient world scenario, for those who may pick up this report and look at other reports that the IEA produce, is a little bit different than what might be seen under a sustainable development scenario. And I just want to quickly outline there is a key difference here. While the efficient world scenario has been designed to achieve economic effectiveness in investment in energy efficiency, there are some key differences around fuel shifting. And to illustrate these again by the carbon emissions, so we have what has been agreed to by countries around the world, and in the sustainable development scenario, this would be meeting the climate change agreement of Paris. We need to achieve this green line. Okay, so this next slide I'm sure you've seen, and which is to say efficiency is going to be one of the key enablers of that. It means not installing technologies that are not best available. It means not locking into a high demand future through the use of inefficient technologies that are certainly being produced, and it means a variety of mechanisms to install this. So I'm going to go through a few of those now. So building energy efficiency. When we look at how things have changed over the last 17 years, since 2000, we have had an increase in demand in activity. In other words, there's more of us. We're occupying more space. We have more economic indicators that are driving that demand for energy. We've also had growth as it relates to structure. So basically, there's more floor space, and we're buying more things, and they're present in buildings. When we talk about building energy use at the IEA, we're not talking about a restaurant's heating for food. What we're talking about is the heating, cooling, lighting of space, of hot water, and those levels of usage. And then what's efficiency done? Efficiency has ultimately reduced the amount of growth that we've seen out of those two activity and structure. And this is clearly an important piece. In terms of residential and non-residential uses, space heating, as we've known, is the dominant source of that energy use. Now, this is partly reflecting where it is that energy is being used around the world. It is cold countries, rich countries. So when we look at space cooling, for example, this is one which we'll keep an eye on. Water heating as well, cooking appliances, etc. Okay, so in moving from 2000, which is our baseline for comparison at the moment, through to 2017, we see this trend. Increase in demand. When we go forward to the future, the efficient world scenario is trying to illustrate that we're flattening out. Demand doesn't increase despite the fact that we're going to have increases in GDP and other increases in floor space. For example, we're going to be building 60% more floor space than is present today. And that's going to be in certain places, remembering that our dominated cold climate, rich developed nations will be shifting energy demands elsewhere in the world. What we find in intensity terms is that the amount of energy we're using intensity is also dropping. So despite the fact that we have this flattening of demand, we do have an improvement in the intensity of energy use per square meter. That's very important. And so where are we seeing these changes? So from 2000 to 2017, what we see here is by end use, space heating, when it goes up, is an improvement in intensity. That's a good thing. And so we see that happening in water heating, lighting, cooking, and appliances, but not in cooling. And this is partly to do with who is uptaking cooling. Where is it going in the world that has not had it traditionally? And where will it go in the future, particularly as we're responding to an increase in temperature? So the fact is that under an efficient world going forward, we need to, of course, continue to improve energy intensity around heating, hot water, lighting, cooking, etc. But cooling needs to be managed very carefully because it's going to be one of the dominant growth areas going forward. In terms of this investment, we talked a lot about investment. Where is it happening? North America, absolutely. Europe, certainly. But also China. I mean, as a global player, they're going to be investing in their building stock. But they're also going to have an effect regionally as well, and it's going to be an important area to watch. From 2015 to 17, these were the growth areas in investment. Where did that go? Well, envelope was certainly one of them. Both in non-residential and residential, there was a focus around HVAC systems and appliances and lighting. So these are just the trends that we're watching right now in terms of where there's a market and where the market is going to be demanding in the future. Looking at continued investment in the future, what we need to do is increase the rate of investment in energy efficiency in our existing buildings and new buildings going forward. And in particular, as we go towards, sorry, I'm just looking at the, going forward to, say, 2040, we have to increase that by at least a third. We're on track, but we have to increase the rate. Where does this go? Again, as I said, heating and cooling and lighting are going to be big areas of investment. The last part, and we were talking about codes. We've been talking about regulations, and we've been talking about what does that mean and translate to. So what the IEA have as a database is to be able to look at how efficiency policies are covering a series of end uses. So from 2000 to 2017, the rate of coverage of different end uses on, say, lighting and space cooling has increased. In other words, the products that are being sold in those sectors primarily have some form of standard associated with them, which is great. These other sectors, end uses, space heating and water heating, not so much. Cooking, pretty much none. The issue is how strong are they? So it's great to have a building code, for example, in Ontario, but if it doesn't have incremental improvement, then that's certainly a baseline, but it needs to be improved over time. So in terms of what is possible by 2040, so we know that buildings' floor space could increase by 60%. Space heating and cooling and water heating offers 60% of that overall savings. And in order to achieve this 2040 scenario of a more improved building stock globally, it has to be focusing on efficiency policies. They need to focus on best available technologies, not current available technology. Current available as installed in an appropriate way, and current available to countries and regions like Canada and Waterloo are in the league of best available technologies when you're going to many parts of the world. So I think incentives to encourage consumers to adopt these high efficiency appliances, whether that's through, for example, bill payments, or whether that's through some form of rebate or rearrangement. And also to be able to talk about these multiple benefits that efficiency offers. So I ran through this quite quickly, and partly conscious of the amount of time that we have before I'm standing between you and perhaps a break. But is to go also then into how we're looking at this issue in the UK. And so what I'm going to transition now towards is this is the report that I helped co-write. Be very interested in for those who want to read it, and if you have any questions, certainly to talk to me about that afterwards. I only covered a small bit of it. The other thing that I was going to talk to you about is the UK, to bring it home to a comparable region in terms of economic growth. Prosperity has its own issues around policies and politicians and choices, but we can go into detail about that. And really to talk about something that we've been developing in terms of our innovation around methods. So I have up here a term that for many of you probably doesn't go together with energy very commonly, and that's this energy epidemiology. And what does that mean? What is this? And so I'm going to just spend a few moments to talk a little bit about that, and then perhaps kind of end on a few few thoughts about innovation in building sciences. I should say my background, actually, I am an alumni of Waterloo, in fact, as is my parents, and my grandfather before that, who attended the Waterloo College before it was a university. So we've had a string of Waterloo-ness here. So I've been in London, and one of the areas that we've been focused on is the existing building stock. And this is partly a recognition that for England, for the UK, for Europe, that the vast majority of our buildings are there. We are not building new buildings. We're retrofitting a lot of buildings, but we need to do better. This, by the way, is an image of Sao Paulo, if you've ever been there before. So why do we need to change our current practice, which I think we recognize, obviously, is we have to do things to improve our energy intensity. It's not just enough to improve the next product being delivered. It's about improving those products that we have today. So we know that we have to be able to reduce emissions. And the fact is that we're investing globally trillions of dollars. This is a huge investment in the future. And the reality, I think, is, as we know in UCL and here in Waterloo, is that we're very good at studying the building. We know everything about that building. We can put as many sensors as we want. We can put all sorts of monitorings and surveys and questionnaires and models. The virtual simulation is able to do this. And when we study the building as a group, we kind of take one building and we just replicate it. But, you know, we know that not all buildings are yellow. Some of them are blue, right? The problem becomes when we're dealing with the population of buildings. How do we study this group? And what is it, what methods do we use to be able to study information that's being derived out of not just tens of buildings, thousands of buildings, but millions of buildings? Billions, perhaps. The idea around energy epidemiology is that a term simply means study of what is upon the population. And when we talk about energy epidemiology, what we're talking about is an energy demand, an energy outcome that exists among that population of the building stock. So epidemiology is something which is data-driven. So when we're talking a lot about systems and smart technologies and sensors, there are methods that exist already in the world to be able to deal with this when we're talking about a population of these systems. And the real emphasis is on empirical evidence, looking at how conditions or outcomes, the fuzziness presents itself across that population, and what are the driving factors behind that. Looking at those slides that you had about what's causing certain outcomes, the fact is that they are there across this stock. And understanding the spread and severity of this condition. When we talk about energy demand and we talk about a single building as a stacked bar of these different end uses and different components, the fact is that that has a wide distribution when you go out and measure these thousands and tens of thousands of buildings that are even seemingly alike. And ultimately, that's just to be able to build an evidence base. And it's about then being able to better inform policy and regulation and incentivize investment, create markets to respond with information. So our crude thinking of it at UCL has been about devising a simplified concept around the health research framework, where you may have socio-behavioral and psychological components, research or understanding of the system, human system. There's environments and exposures that sit outside of that. And there's biomedical and physiological systems that are internal. And what epidemiology does is it draws from all of those spheres to create a better understanding of the things that are happening in that population. So really, we apply this, we adopt it, and adapt it to what we're doing in energy terms. And we have buildings and technologies, we have people and behavior, and we have environments and society. And these are the regions where energy epidemiology needs to draw from. So it is not only multidisciplinary, but it's interdisciplinary, which means that it's tackling a problem that is common across multiple disciplines and reframing it. So you go to the doctor, and what's the first thing a doctor does when they prescribe some medication? You look at what the side effects are. How does that population respond in the pill? Do you understand the risks? Does the treatment work the same for everyone? And how do we prescribe the treatment with other treatments, or how do they interact? All of these types of approaches, which I think we can think about when we're talking about buildings and investment and retrofit, is certainly something that we should take note of. And all of these are coming from epidemiological methods of study. So the fact is that we wouldn't want to invest billions in building energy efficiency without having some evidence base about how these treatments work. And that's really the focus. So ultimately, what we're trying to push for is shifting towards this low-carbon society means improving this population approach of building evidence. And we have a cycle of being able to, yes, undertake detailed laboratory studies, looking at pilots, looking at how the nuance of delivery and these systems work, but then being able to scale out and scale up towards saying, we're not studying every building in Canada, but we're going to build representative samples, we're going to build evidence to inform how policy works. And then maybe, there's too much to think, regulation will be a bit more consistent. Who knows? Maybe policies will be a bit more consistent. So the point here is, if we were to treat this like a health risk, we would want to be able to have a framework for interdisciplinary research. We'd want to look at population studies that are using empirical data. We'd be able to look at protocols. I think this is another thing. We talk about evidence, but we don't necessarily talk about how that evidence was developed. Is each piece of evidence that I present you with the same quality? I think the other crucial thing is about feedback of findings. Where it is we have failure. There's a term in the health delivery treatment world, which is, did the mechanism fail, or was it the delivery mechanism that failed? So knowing whether or not the treatment itself just isn't up to the job, or whether it was the process of delivering it. And that's really important to know what part was undermining and resulting in what we know as the energy performance gap. And ultimately, this comes around research translation and engagement, being able to bring information to policymakers, investors, et cetera, to understand the issue they're dealing with. I'm cognizant of the amount of time, so I had a few slides here about the UK, but rather than go through these, I'm just going to skip some final thoughts about what it is that we could be doing. There's a chance I mess up, but maybe I'll just quickly go through them instead. Okay. So, ending on perhaps a moment of lightness and positivity is what can we do to achieve our targets as it comes down to improving our energy performance, our energy intensity, reducing greenhouse gas emissions to be an efficient world, meeting our sustainability targets in terms of equity and empowerment around energy access and use globally, and of course here in Canada and the UK. So, some thoughts on innovation in building science, which I can't compare to the great ideas and statements that have been made throughout the day. Many of them are not new. Obviously, one is to use systems thinking. I just think by that, what we're not talking about is the wider systems of people and behavior, the socio-technical interactions that are occurring. And this is what, as you said about building for people, this is completely the right approach. The business models, obviously. I mean, it's not rocket science, it's building science, which I have to say I think is more complicated. And just as a note, the US invests trillions of dollars per year in construction, while NASA costs $20 billion. Okay, the scales of comparison investment of something which is so technically detailed and as rocket science, in this sense, building science and building construction practices, I mean, there's so much more investment happening, and yet we're pulling in lots of different directions. And this is the difference between those two comparisons. One, they're shooting for the moon, perhaps Mars, while ours, we don't have a concerted effort, but we have one if we're focused on our climate goals. Obviously, talking about information technology, teaching your buildings how to think and how to learn. And this is really around building systems for buildings to be able to respond, yes, better to the user, better with each other, better with the grid, better with the environment around it. And the cost of these types of systems have dramatically dropped. And that's a real opportunity for how we can better use information to support this. And I think learning to navigate intersections. And this is where when we talk about interdisciplinary problems, energy, environmental quality, and health intersect. Equity and technology access intersect, and tackling these problems requires, as is being presented, both architects, engineers, social scientists, economists, planners, et cetera, and that's the real world, ultimately. And so I have thoughts around 5 ways to achieve the low-carbon energy transition that we need in the built environment. And the first is collaborating outside your discipline, as I've just said, to be able to challenge different choices and different systems to build a better product together. And I think that the examples we saw today here are on that way, on that track. And building consensus through inspiration. I think this was the point where people aren't buying square footage. They're buying their future, a place to live they call their home, their business. This is the growth potential that they see. And being able to convince them why performance matters is about achieving those, that inspiration of their vision of the future. Don't take no for an answer. And obviously that's much harder than it sounds. But I think what I mean here is if it's technically feasible and it achieves our common goals and the goals of the project, that build evidence to support those designs, those choices. Because I think that if it's an obvious and intuitive choice, we would be making them. And so maybe these are, but we just have to take better approaches around convincing people. Don't let go. A good building design includes that feedback process, and that's absolutely critically and crucial to the future of our building performance. It means you have to teach your buildings to think and to learn over time, and it means that the systems that are being now adopted into these buildings are really about achieving that outcome. The user becomes that invested occupier of the space, but you're delivering that with them. Number 5 is using advanced technologies don't forgive bad designs. And ultimately, at the very end of the day, is we have to be creative and think, will my building last 100 years? Or in the UK and Europe, will it last 2, 3, 4, 500 years? Because that's our future. Thank you.
Somebody has a question or so. This may be testing your patience, but after such a wonderful talk, Ian, thought-provoking, and an excellent summary, perhaps you may or may not have a question or two. So we'll take 2 questions max, if you have any questions for Ian.
Questions?
Over drinks.
It was a clear, wonderful presentation. Thank you very much, Ian. Thought-provoking at that, and thank you for hanging in pretty well till the end here. We are actually on time exactly. If you accept that we did a 15-minute shift to start, so we're on time that way. It is now my pleasure to call it an end to this particular symposium, but I thank you for your participation, and I think it's been a wonderful opportunity, at least for me, to understand the perspectives of so many colleagues who have been kind to share their ideas and thoughts about what do we do now to get ourselves to a low-carbon energy future, and buildings being a very important part of that whole tapestry of discussions that was, to me, an enlightening day. So again, thank you. Again, do stay in touch with us here at the Waterloo Institute for Sustainable Energy. We are a multidisciplinary institute and quite open to working with you, any one of you, and try and advance these solutions one step at a time. Before we end, I would like to thank the staff at Wise Armagan and Jessica and Laurie, who put an enormous amount of effort to get these sorts of events together. So I thank you very much, and have a wonderful evening. Bye now.